Hi, Dan Westgate from Brilliant Ideas, and in this video we're going to be doing another load test where we're going to apply a 3-ton point load using our test rig that we've had manufactured bespoke for this purpose. And what we're actually trying to demonstrate is the difference between UHMW-PE mats, which stands for ultra high molecular weight polyethylene modules, or what you can see around here, which is our modules, which are manufactured from extruded aluminium called ALIMATS. The ALIMAT module is 1.74 metres by 0.58 metres wide by 60 mil deep, and it's made from an extruded aluminium process. And the polyethylene mat is 1.8 metres long by 0.6 metres wide and 50 mil deep, and it's manufactured from polyethylene. Now, the purpose of this test is we don't actually believe that polyethylene mats are fit for purpose when it comes to physically distributing or spreading load from a crane outrigger. We don't dispute its ability to transfer load in compression on hard surfaces, but a lot of the design guides, namely the Construction Ground Conditions for Plant 2014, does actually state hierarchy for strength, which is the compression being steel, aluminium, nylon, polyethylene and timber. But in stiffness, which in our opinion is the most important, the hierarchy of strength is actually steel, aluminium, timber, nylon and polyethylene. So essentially polyethylene being the weakest in stiffness. Now previously we've done a 1-ton test on this particular module and it deflected 102 mil overall, but the permanent deflection was something in the order of 37 millimetres. Now to get this module level again, we've had to turn it upside down and apply a load so we can actually have it level, which again highlighting another reason why we don't believe that they're suited for crane outrigger mat systems. So Philip, if you can start applying the load, and we'll no doubt see very similar results. Now in this test we're going to apply a 3-ton load. You can see here we have a steel plate on top which is 500 mil square, and it's made of 30 mil thick mild steel. And its purpose is to actually work very similar to a crane outrigger. So it's actually applying a very evenly distributed load over a 500 mil square footprint. So Philip, if you can just give us a reading on. So we're at half a ton already. So if I just crouch down here, you can already see visible signs of the mat deflecting. And if I come around here to the ALIMAT system, I can't actually see any visible sign of any deflection occurring at this stage. That's at 1 ton, is it? Okay. So the last test we did, we halted it at 1 ton, and we had permanent deflection of 102 mil under this test. And already I can see a gap between the steel plate working as the crane outrigger and the polyethylene crane mats. Now, when it's deflecting like this, it's not spreading the load horizontally and reducing the pressure below the mat surface. It's essentially will be triangulating almost from the actual steel plate, which is the 500 mil square plate I referenced earlier. If you give us another reading, please. Nearly 2 ton. So we're nearly at 2 ton. And at this point, you can really see the load being excessive. And if I come round, still no visible sign of deflection on the ALIMAT system, and I certainly can't see a gap like I can with the polyethylene system. And this system is still widely used in the industry, and we do question as to why. So we're now at 2 ton, and I would say that the deflection is significant. So Philip, I would actually halt the test. I don't see any point in this test continuing. So what was the reading on this level here? 2.25 ton. Okay. Now the literature for this particular module does state that this module is good for 54 ton. Now we might not necessarily dispute that, but it must mean that it's only good for 54 ton on compression, whereby it's actually on extremely solid ground where crane mats are probably not even required. Now crane mats are supposed to perform where load spread is required and the ground cannot take such loading through compression. Now coming around here, again, there's no visible sign. But what we'll do is we'll take some readings and we'll come back to you with the results. Okay, so we've taken some readings after the test where we applied a 2.25 tonne point load at mid-span of the UHMW-PE mat, which is ultra high molecular weight polyethylene, which is a common mat system used in the industry. And when we went to take the post-test reading, when the load was held at 2.25 tonnes, it actually stopped passing a load, but the deflection carried on going down, so we couldn't actually get a reading, which does indicate that it's failed. But at this point, we did take a reading, and the overall deflection from the pre-test reading was 328 millimetres. Now, coming round to the ALIMAT module, the post-test reading was 3 millimetres. And what we're going to do, we're just going to lift the load cell up so we can remove the steel plate and then see the condition of the UHMW-PE mat or the polyethylene mat. So Philip, if you can jack it up, please. So it is springing back. And what we'll do, when this is clear, we'll remove this so we can just visually inspect if it's going to return to level. But based on the reading not being able to get any higher, it would suggest that the module's definitely reached its elastic limit, but we also believe it's totally failed. Okay, so if I want to pull this away. Okay, so there we have it. It's permanently bent, which has obviously reached its elastic limit structurally, and in our opinion, not fit for purpose to be used as crane outrigger mats. Bearing in mind, this material is also used widely for crane pads as well. And then with the ALIMAT system, there is no visible evidence at all of any permanent deformation. These results will be recorded post this video and put into a formal report. Hope that's of interest. Thank you very much.